I'm like, seriously, right? Maybe I'm not eating. I've been had a long, probably the fact that I had a pop this morning is why I'm drinking. All right, so, on your boards, before I draw it, make sure that you first have the thing that identifies it is a right triangle. What would be that thing? Angle. Right, the right angle should be on there. Next, we have the change in x. So is that vertical or horizontal? Right, horizontal. X-axis is horizontal. X-axis is horizontal. X-axis is horizontal.
Jack.
What?
Oh, you didn't even look up. X-axis is horizontal. This is horizontal.
Sure.
I got that question wrong.
Think of the horizon.
That's what my mom told me.
The horizon, horizontal.
I was like, why?
I thought that was that. No, not that. Diagonal was the. What's the one that goes up?
So
Vertical.
vertical is the y-axis.
Oh, this is, yeah.
Because the lines on the V are like straight.
Oh, that's a good one. The lines. Okay, the lines.
H
On,
has a straight line.
I like that. Okay,
Well,
so the
vertical
H
is-
has this, so horizontal. The lines on the V up and down. I like that. And then you should have the slope. Where's the slope located on a right triangle? Hypotenuse. I know, you got it. And then you need to indicate where your slope angle is. So you would just use this little symbol right here. So that should be drawn somewhere on your triangle, the slope angle. The slope angle is located is made up of the x-axis and the the slope. I see a couple people labeling it differently.
Wait, what did you say?
The slope angle is made up by the x-axis and the slope. So it's like, it starts on the floor, so horizontal, and then it goes like up. So that's increasing slope angle, that's decreasing slope angle. So we should have a right triangle drawn. Right here. This is the change in y. This is the change in x. Because when we're looking at a coordinate plane, this is the x-axis and this is the y-axis. So it's like this triangle fits into this corner right here. That's fine. Slope is right here. How do we find slope? Right, change in x over the change in y. With what letter do we use to represent slope? M, right? So makes sense because this line here is slope. So it uses the y and it uses the x-axis. And then with this being the x-axis and this being the slope, that means our slope angle is right here. Some of you, I have you marked it like this. That just tells you that that's a congruent angle to something else. So don't do that. So the little curve thing means congruency. This is like a variable we would use. So we can't use x and y. Sometimes it might be a, but right now for ours, it's just slope angle looks like that. Okay, so yesterday we talked about one special slope angle and slope ratio. So I want you on your slope triangle, because that's what this whole thing is, slope triangle, I want you to draw me the 11-degree slope angle on your triangle, and then tell me what the slope is. So the triangle we did yesterday had an 11-degree slope angle, and you need to label the sides, the slope on the sides. The slope, label the two sides that make the slope. There we go. Got it.
I'm still so.
So the slope angle of 11 degrees has a special slope, and you need to label the sides. of the slope triangle that we learned yesterday.
Am I right?
The original. Like you have the slope written there, but you'd have the sides labeled different.
Because it like reduces it down.
I mean, yeah, I guess it's right. You can use that one. I wasn't looking for that, but yeah, you can use that one. Okay, so yesterday, the first triangle that we learned, yeah, it had a slope angle of 11 degrees, so therefore its slope ratio was 1/5. So slope angle equaling 11 degrees has a slope ratio of 1/5. So when you're looking at your trig table, so everyone pull out your trig table that you should have grabbed.
Just like yours.
Not yet. It's getting there, but this is real trig yet. But we're on our way. After Christmas, we'll be there. So the first one on here, it just has the angle and it has your triangle labeled for you, telling you that slope is changing y over change of x, and then they already have this triangle drawn on there for you. So they have the 11 degree one. So anytime that you have a slope angle of 11 degrees, you have a slope ratio of 1/5, and vice versa. Anytime that you have a slope ratio of 1/5, that means the slope angle is 11 degrees. Okay? So, in using that information, let's look at problem number 12. So problem number 12 gives you a slope triangle. What's the slope angle in this triangle? 11, right. So what are we going to do to figure out what the measure of y is for this triangle? So we know that the slope angle is 11 degrees. What else goes with the slope angle of 11 degrees?
And we use 1 and 5, but if that's 20, and you multiply by 4, so what does that equal?
So the 11 degree angle tells us to use a slope ratio of 1/5. But this triangle isn't exactly like our 1/5 triangle over there, right? We know that they're similar. The reason they are similar is because they both have an 11 degree angle and they both have the 90 degree angle. So by angle, they are similar triangles. So we get to set up a proportion. So since this triangle is similar to this triangle, I'm going to use this triangle slope and set it equal to this triangle slope. So what is the slope of my triangle up here? So the way you figure that out, look at the y direction first. What is the length of the y direction? As given. Y, yeah, it's y. So the change in y is right here, and they tell us it's y. What's the change in x? Right. So the slope of this triangle is y over 20. So now, since we used that slope and this slope, we can now figure out y by cross multiplying. So I'm just going to go through the steps of cross multiplying because last class was having trouble. So 20 times 1, equal sign, and then 5 times y, and then carry it out by dividing by 5 to give you y equals 4. So again, I used similar triangles, this triangle and this triangle. I used the slope of that triangle, set it equal to the slope of this triangle to find the missing side. I want you now to do problem 13b and 13 E. So 13B and 13E is what you're doing right now. No, sorry. Guess you can't do that one yet. Do 13B.
That's 413.
I don't know, I didn't know. I think so.
So here, it looks like you're trying to compare angles and sides. Can you do that? No. So let's just do your slope. So you recognize that we have a slope angle of 11. Using our chart, 11-degree angle gives us a slope of 150. So we need that ratio. That round. Okay, what's the slope of this triangle? No, the slope. Like the slope of this triangle. This one is this triangle. What's the slope of this? So we need to do the y direction on top. And the x direction on bottom.
So do you, like, if you were a basement, but like, I know you have your own
And then
version.
7 equal across.
No, I thought you did. I don't start anything
Okay, so this one, the slope angle is what? The slope angle is 11 degrees, so therefore we go back to the only one we know. So it has a slope ratio of 1/5. And then we have a triangle that's bigger than our original one that we used. So what's the slope of this triangle? Right, 100 over x. And then you cross multiply to get x equals what? 500. Okay, so for problem A, what's the slope angle? It's 22. All right, well, we do have a triangle. The only one we know right now is the 11-degree one. How can we go from 11 degrees to 22 degrees? Multiply by 2, right? So if I multiplied the angle measures by 2, what do you think I'm going to do to the ratio? Right, multiply, well, not the sides. It's the, it's
Oh, yeah, the ratio.
yeah. So if we multiply the slope angle by 2, I'm going to multiply the slope ratio by 2 and get what? Multiply by 2. Not 2 over 2. Yeah, right? 1/5. 2 is 2 over 5. If you do 1/5 times 2 over 2, this is just 1. So it's not the same, right? So we get 2 over 5. Which makes sense because if I take 2 slope ratios of 1/5, so I had it at 11 degrees at 1/5, now I need another 1/5. It increases and it doubles to 22. So now this triangle is 2 over 5. So you need to add that to your table. Add that to your table. You have to keep this table for a while. So you need to be putting these triangles in your table.
Where's yours go? Shop in the next room. Okay. I'll drop it under the next note when we get up.
All right, so with this information, you can now do problem A and E. So go ahead and do those 2 problems. Okay, well, we have a slope angle of 22. So when we have a slope angle of 22, what's our ratio? Okay. And we're going to set that equal to the slope of this triangle. So you did x over y. Slope is y over x.
Oh.
Yeah. Yep, now cross multiply.
50 and 10.
What's the slope of this triangle? What's the slope of this triangle? If it's 22 degrees, then we're going to keep similar triangle with 2 over 5. Well, what's the slope of this after? If you don't know the angle, what's x over y? Change in y, change in y over change in x. You got that? Alright, so we recognize for A that we have a 22-degree angle, so we know that all 22-degree angles also have slopes of 2/5. And then to figure out this missing one, we have to use this slope triangle. So what's the slope of this triangle?
Y over 25.
Right, it's y over 25. So I guess like for what you were saying, like, yeah, it does have a slope of 2/5, but if we put 2/5 twice, it's not going to help us solve it. So in the end, when we do solve for y, yeah, it's going to equal 2/5. So we cross multiply, what do you get for y? 10. All right, part E, what is it asking us to find? Right, we have to find the slope angle. So they already give us the two legs. So therefore, from that information, we can figure out the slope of this triangle. What's the slope of this triangle? Right, 20 over 50. All right, so we know that all of our slopes, if it's not one of our original ones we started with, they can reduce. So what does 20 over 50 reduce to? 10 over, did you say 10 over 25? Okay. And then what? 2 over 5. Or just recognize that anytime you have zeros on top and bottom, you get to cancel them out. It's like dividing by 10. Yeah. I mean, either way is right. So we have a slope of 2/5. So therefore, when we have a slope ratio of 2/5, what angle goes with it? Right, 22 degrees. So therefore, this missing angle measure is 22 degrees. Okay, on your boards. I want everyone to answer this just on the board. Don't say anything out loud. I want to check something real quick. So make sure that you're just looking at yours. If you're wrong, you're wrong. It's okay. I need to see what's going on. Letter D. I want you on your board just to write what is the slope of this triangle. For letter D, what's the slope of that triangle? Get rid of the x. Why do you have x equals?
Oh, wait.
Oh, you got an answer? Okay. Yeah, so remember slope is just the change in y over the change in x. So slope was either you could have wrote 4 over 4, 1 over 1, or reduced it completely and gotten 1. What do you know? What do you notice about this triangle in comparison to the other ones? How's this one different? Okay, has a different slope. What else do you notice about it? Right, both they have two sides that are the same. So it has a different slope than the other ones, but it also has two sides that are the same. What kind of triangle has two sides that are equal to each other? Don't say equilateral. It's isosceles. Remember, equilateral means everything is equal. So this is an isosceles triangle right here. So okay, so you'll see it marked sometimes with the two tick marks. So if both of the legs are congruent to each other, this is a right isosceles triangle. And we know from the triangle angle sum theorem that all three angles have to add up to equal what? Yeah, 180 degrees. Well, we know that here we already have 90 degrees taken up, right? So we're left with x plus y equals 90, kind of like what we did yesterday when we were trying to figure out that missing angle in the Leaning Tower of Pisa. We knew that 90 got to be taken away, but we had two different angles adding up to equal 90, and we couldn't figure it out. But here we have a right isosceles triangle, So what do we know also about two of the angles in a right isosceles triangle? If two sides are equal, then, right, the two angles that are across from it are equal. So therefore, if these two angles are equal, and there's only 90 degrees left to use up, what's the measure of each of those angles? You have two angles that are equal. They get to add up to 90. What's the measure of one? 45. So that's our next triangle. We have our 45-degree slope angle. And then we know that our slope ratio is just going to be 1/1. Later, we'll start calling that a 45, 45, 90 triangle. So make sure you have that drawn on your sheet under the 45-degree one, or besides, I guess, the 45 degrees. So then you guys should now be able to do letter C. You can do it the super fast way, or you can do it the not super fast way, but you can still be right.
Is
We're doing this one. We already did this one.
Oh,
No, that's an E. It's just my projector super stupid. It doesn't, like, it's not bright. They're supposed to be getting me a new one. All right, so how many of you used a proportion to solve this? Meaning you took two fractions and set them equal to each other. All right, so if you're using the proportion, what are my two fractions that I'm going to use? Okay, and okay, 13 over A, and then you get A equals, right, 13. All right, what's the other, so the other people, you guys did it the other way? Anyone? Anyone not use the proportion? Okay, go ahead. Yeah, so if you recognize that this is a 45-degree angle here and 90, that means this is automatically an isosceles triangle, so therefore the legs have to be equal to each other, so A has to be 13. Or you recognize that the slope has to be 1/1, and the only way you get that is if these two numbers are the same. All right, look at F. What we got going on in F? Can we do that one?
That's like 79.
Yeah, it says 79. I just could have your books with you.
No, because we don't know the,
Yeah, I don't want to draw it up there. So this one, I'll draw it bigger here. We have a 79-degree angle, but we don't have any information about a slope angle that is 79 degrees. Got any thoughts? We don't really have anything over here that we can say, oh, this number doubled or tripled, right? Because this one would have to have 5s in the ratio or just doubling, and 79 is a prime number, right? Yeah. So only 1 and 79 go into it. Doesn't have any relationship with the 45-degree angle. We can't use anything that we have over here. Just take a look at it for a minute. If you were looking at this on a test, let's say you're completely lost, you really don't know what your next steps are. What's something that you might try anyways?
I mean, the other people do it.
The other angle? Is that what you said? Okay, so let's figure out that other angle. What is it?
You do 180 minus 90 minus 79.
Yeah, we've already used up 79 and we've already used up 90 degrees, so what's left from 180 for this to be?
11.
It's 11. Have we seen 11 before?
Yeah, it's already good.
Yeah, we've already used it, right? So does that mean that I can just leave this triangle like this and say, oh, okay, well, 11 degrees gives me a slope ratio of 1/5, and then the slope is 7 over, or y over 7? No, right? The slope ratio is, or the slope of this triangle isn't y over 7 because this isn't a slope angle right now. So what can we do to make it a slope angle? I want this to be down here.
If you turned it,
Yeah, exactly. If I turn it, I can now solve it because we know through rotation, it doesn't change anything. It just moves where it's at. So I should say 11, not 110. So what is going to be y in this case?
well, isn't the X on the
Well, it's x. So whoops. Oh, what? So our slope angle is 11, so that means we get to use 1/5. And what am I going to set that equal to? What's the slope of this triangle?
1 over 7?
So slope is y is change in y over change of x.
7 over y?
This is the y direction. This is the x direction. So just because the variable is y, it doesn't mean that's the axis. That's how they're going to throw you off. I hate that. I wish they would just use A, B, C. But they don't. So therefore, what's y equal?
35.
35. So on this one, we had to move the slope or the angle that we knew into the actual slope angle position. So did we learn any new angle yet though? No, because we still use the 11 degrees. But what you did do was you found out that, oh, well, I can find the missing angle to see if it's one of my angles that I already know information about. So in looking at this one, we have the exact same triangle here. And we have it drawn to where 11 degrees is the slope angle. And we already solved that this part right here is 35. We found that length. So a slope angle of 11 degrees, I shouldn't say equals, has a slope ratio of 1/5. If I turn this triangle now to where I'm using the 79 degrees as my actual slope angle, what's the slope of this triangle? So what's the change in y?
35.
And what's the change in x?
7.
So what's the slope of this triangle?
5.
Right, 5 over 1. So therefore, a 79 degree angle has a slope angle of 5 over 1. What do you notice? Cohen, what do you notice about the stuff that we just did? What do you notice about this information?
Flip.
It's flipped, right? The 11-degree one is 1/5, the 79-degree one is 5/1. So they're reciprocals of each other. Okay, well, maybe there's some sort of relationship then between these two numbers. Is there a relationship between 11 and 79? I like it, Noah. What'd you just discover?
Well, I just did 79 divided by 11.
Okay, use a different operation. Okay, which one did you try?
Multiply.
Okay, use a different operation.
Is 90.
Ooh, they add up to 90 degrees. And what do we call angles that add up to 90 degrees?
Right angle.
That's just one angle. And we have two angles that add up. Complementary, right? They do end up, if you put them together, yeah, they make a right angle. But these angles are complementary angles. Yeah, right. Or they're complements of each other. 11 degrees is a complement of 79 degrees, and 79 is a complement of 11. But it gives us a new triangle. So we have a 79-degree slope angle, gives us what slope ratio? Haley, what slope ratio do we get when we have a slope angle of 79 degrees?
25 over.
Right, 5/1. So you can add that one to your table. Guys, the way this helps you is if you answer the questions, because you'll remember that moment in class maybe when you're trying to regurgitate this on an ACT test or something. All right, so 79 and 11 go together. Do we have any other ones that are going to have a complement? Right. Yeah, we have a 22. So that means we must be able to figure out a 68-degree one. So a slope angle of 68 degrees is going to have what kind of slope ratio? Right, 5/2. If its complement was 2/5, then that means the reciprocal is going to be equal to its slope ratio. So therefore, anytime that angles are complements of each other, their slope ratios are reciprocals, meaning just flip their fractions over. So now we have 5 total triangles that we could use on our sheets. Is there going to be one for another one that we match up to the 45? What's the complement of 45? Right, 45. So does that make a new angle for us? No. So right now we're only going to have 5, but we now should have realized, hopefully, that anytime that we figured out one angle, that leads us to another angle by finding its complement. So for example, on your paper, if you find an 89-degree one, then you'll know what the 1-degree one is, and so on. So on your sheet, we have angles that go up to 89, but there's an infinite amount of slope angles, which means there's an infinite amount of slope ratios. Do you think we're just going to fill out a sheet for every single angle that exists in the world? No, we're not going to do that. We're doing it this way right now because it's super important that you learn the terminology, that the vertical sides that make, or the vertical and horizontal sides that make up the triangles are the axes. So change in Y, change in X. These two make up your slope. And then your slope and your change in X make your slope angle. This right now And knowing that slope is change in y over change in x is the most important thing of the lesson so far. So after, for yesterday and today, this is what you need to be mastering. So if you can do this, Cohen, if you can do this, then you're doing really well. So how many of you feel great about just this part of it? There's some people feeling pretty good about it. Okay. We'll keep doing this every day. If you don't get all of this, that's fine. This calculator is going to make it 100% easier. Homework.
It's an egg puzzle.
It is an egg puzzle. So homework for tonight.
I did it, but I didn't.
I thought they
I
were
did
the
the
same
questions
thing.
without the video.
How can you do it
I did
without
all
the
the
video?
questions, but like the video's not there.
Oh, you got to let the video run for it to grade it.
I just said, okay.
Yeah, just let the video run. You'll be all right. Yeah, so it's another ed puzzle, and it's just the second half. So it's just this